One of the standout advantages of Opal Infinity Zeolites is their ability to fine-tune product distributions in downstream processes. Unlike thermal pyrolysis, which often yields a wide molecular range of products, these zeolites enable precise control over end products.
Good morning, everyone. I hope everybody's enjoying the plastic recycling show. Come on, a little more enthusiastic than that. Everybody had their coffee today? What's going on? We need more people in. Everybody start walking in, sit down. So my name is Faria Avis. I'm the Senior Manager for New Business Development at Zeolyst, part of Ecovist. I'm a chemical engineer by training, and I have over 19 years in oil and gas and energy, creating value through efficiency, innovation, and sustainability. Today, my colleague Nate Rocco and I will be introducing our Opal Infinity portfolio, demonstrating the value our solution can bring to customers in advanced recycling, or chemical recycling, or molecular recycling, whatever you want to call it. Ecovist is a specialty catalyst and services company with a strong focus on sustainability and innovation. The company operates through our two main segments, Eco Services and Advanced Materials and Catalysts. Eco Services segment specializes in sulfuric acid recycling services and logistics for alkylate production and refinings. It also provides virgin sulfuric acid for application such as mining, water treatment, and industrial processes. Our Advanced Materials and Catalysts segment offers advanced silica along with our zeolite-based catalysts for application like polymer technology, refining oil, sustainable fuels, and emission control, just to name a few. Founded in 1831 and headquartered in Malvern, Pennsylvania, Ecovist has a long history of innovation and customers' collaboration. The company is committed to enabling sustainable-driven solutions and supporting our ecological health. We do have a global presence, and we do have a lot of end users, and we will discuss some of them. Ecovist offers a wide range of advanced materials and catalysts designed to support various industries. Here are some few that I would like to point out. For our advanced silica, we have our immobilization technology that involves attaching enzyme to specialized silica support. This process enhances the enzyme stability and allows for their reuse, significantly improving the economics compared to a traditional liquid-based systems. Also in our advanced silica, we have our CO2 capture technology, where we use amine functionalized membranes and composites to absorb CO2 efficiently from the atmosphere. In Zeolyst, we have our zeolite-based technology supporting renewable diesel and sustainable aviation fuel by providing dewaxing process, which are crucial for converting renewable diesels into high-quality diesel and aviation fuels. And last but not the least, in our zeolite, we also have our Opal Infinity portfolio, offering advanced zeolite solutions for plastic recycling, enabling the circular economy, providing efficient recycling of mixed plastic waste into valuable products, reducing our environmental impact. These technologies are crucial for advancing sustainability and achieving greener and more efficient industrial processes. It's not working. Okay. Ecovyst is known for its strategic partnerships with Shell through our Zeolyst International, which focuses on zeolite-based technology. Zeolyst International is a leading global supplier of specialty zeolite powders and catalysts. It was founded in 1988, and our partnership is going strong even today. From the beginning, Zeolyst focused on developing high-quality zeolite powders, catalysts, and absorbents. Zeolyst combines the expertise of our parent companies, Ecovyst and Shell Catalysts and Technologies. The company has continuously invested in R&D to innovate and improve its products. Zeolite development and scale-up are conducted at our Conshohocken, Pennsylvania site, R&D center. Our hydrocracking and petrochemical catalysts are developed at our Shell Technology Center and also at the Shell R&D Center here in Amsterdam. Zeolyst operates state-of-the-art manufacturing facilities in Kansas City, Kansas, in US, and in Delfzijl, Netherlands. The company is ISO 9001 certified and follows a continuous quality improvement philosophy to meet and exceed customers' expectations. There is a tolling agreement with Shell and Gantt as well, and we work with them hand in hand. Zeolyst products are used in various applications, including renewable and standard refining application and petrochemical and environmental remediation applications. The company offers flexibility to customize zeolite for specific application, optimizing process for maximum success. Zeolyst International has grown from its inception in 1988 to become a global leader in the zeolite industry, thanks to our commitment to innovation, quality, and customer satisfaction. Here, I just want to give you an introduction into our Opal Infinity portfolio. We have a range of different catalysts that can be used in many different applications. Our Opal Pure is used for clean air applications, such as emission control from vehicles, reducing the amount of NOx and absorption of VOCs. So it's a point of generation type of technologies. Our Opal Velocity has a high-quality white zeolite that's developed for enhancing catalytic activity and selectivity, used in hydrocracking, petrochemical refining, and environmental remediation, and few synthetic chemical application. Our Opal New is our custom zeolite designed for a variety of different applications. Our Opal Renew, as the name would say, enables renewable fuels and sustainable aviation fuel production by providing catalytic dewaxing for renewable diesel and oligomerization of alcohol for aviation fuels. Our Opal Infinity zeolite is used for our advanced recycling application, efficiently catalyzing pyrolysis for recycling mixed plastic waste. The Opal portfolio by Ecovyst represents a significant advancement in zeolite technology, offering tailored solutions for diverse applications from renewable fuels to plastic recycling. At Zeolite International, we pride ourselves on our collaborative and partnership-driven approach with our customers. Our mission is to provide exceptional value through technical collaboration and innovation. By working closely with our customers, we develop tailored catalytic solutions. Zeolyst emphasizes agility and speed to market in its operations. By leveraging agile methodologies, we can rapidly adapt to market changes and customer needs, ensuring that the advanced materials and catalysts are delivered efficiently and effectively. This approach helps us stay competitive, our customers stay competitive and responsive in a fast-paced industry. We focus on creating differentiation and innovative solution while offering continuous support throughout the life cycle of the Catalyst and technology platform. This commitment ensures that we not only meet but exceed expectations, foster strong and long-lasting relationship with our customers. Zeolyst International provides innovative zeolite solution for advanced recycling. I will let Nate explain how Opal Infinity helps to facilitate the recycling of mixed plastic waste and supporting circular economy. Here you go, Nate.
Oh, thank you, Faria, for the great overview of all the sustainable applications that Ecovist and Zeolyst supports. So I'm Nate Reckel, Senior Research Chemist with Zeolyst International. I've been developing zeolite catalysts for about 15 years for various environmental applications. And I'm the technical lead for advanced recycling catalysts. And I'm excited today to tell you about our Opal Infinity zeolites for advanced recycling. So we are all here at PRSE to support the circular economy of plastics, either directly as recyclers or indirectly supporting recyclers. We know that hundreds of millions of tons of virgin plastic are produced each year, and less than 10% are being recycled. That means the vast majority are either being incinerated, landfilled, or mismanaged, and ending up polluting our environment. So we need advanced recycling technologies to combat this global plastic waste crisis. Our Opal Infinity catalysts enable the plastic circular economy by enhancing pyrolysis of end-of-life plastic, increasing the activity of the pyrolysis process, and helping control the product selectivity. At Zeolyst, we have two offerings for our Opal Infinity catalysts. First, our Opal Infinity zeolite catalyst for primary conversion or in situ conversion, where the catalyst is added into the pyrolysis reactor during the pyrolysis process to boost the activity of the pyrolysis reaction, lower energy costs, and have increased control of the product selectivity. We also have Opal Infinity zeolite catalyst for pyrolysis oil upgrading after the pyrolysis process to help remove and de-wax the heavy hydrocarbons, and also hydrocracking catalyst for further pyrolysis upgrading. I do not have time to talk about those catalysts today, but please stop by our booth, A26, right behind us. We'd love to tell you more about them. So I know a few of you in this room know how customizable a catalyst solution zeolites can be, but others may never have heard of them before. So I just love to go through a few small parts of zeolite catalyst we can customize for a specific reaction. I'd like to start with the composition of the zeolite and the local conductivity. Zeolites typically consist of aluminosilicates, an aluminum and a silicon tetrahedrally bound by oxygen atoms. This gives the zeolite very high hydrothermal stability, and often the times for the zeolite to be reused and regenerated. When we introduce aluminum into the framework, we create a charge misbalance that we can balance with a cation, and in the case of a proton, we create a solid acid catalyst. We also have the ability to substitute other elements in the framework and exchange other cations into the extra framework to tune a zeolite catalyst specific for your application. Next, we'll talk about the structure or the conductivity of the aluminosilicate framework. There are over 200 zeolite topologies that have been discovered. The topology describes the pore size and the conductivity. This is why zeolites are also known as molecular sieves. So we can tailor a zeolite structure specific for your application. And at Zeolyst, we have numerous zeolite framework types in commercial production. With our skill in zeolite product development and production, we can also control the crystal size and shape of the zeolite crystals for your specific application. And finally, we're able to offer our catalyst in many forms, whether it be a powder, a formed extrude, beads, or spray-dried material specific for your process. At Zeolyst, we are your partner for zeolite catalysts for advanced recycling, from catalyst concept to commercial production. I work at our R&D center in Conshohocken, Pennsylvania, right outside of Philadelphia in the United States. From there, we're able to provide gram scale samples for your initial catalyst testing. On that site, we also have a semi-works plant where I can work with our process development team to rapidly provide kilogram scale samples for continued catalyst evaluation. We have 2 world-scale production plants, one in Kansas City in the United States and one here in Delfzijl in the Netherlands, to provide commercial scale quantities of catalyst for your process. At our R&D center and our plants, we have the characterization tools to develop our zeolite catalysts and understand their properties, and also ensure the quality of our catalyst, commercial catalyst delivered to your plant. We also have a suite of catalytic testing equipment specific for advanced recycling to be able to develop our zeolite catalysts. We have a twin screw compounder for preparing zeolites polymer samples for pyrolysis. We have a thermal gravimetric analyzer for microscale pyrolysis experiments. We also have a gram scale fixed bed benchtop pyrolysis reactor where we can generate pyrolysis oil and pyrolysis gas for analysis, and a suite of gas chromatographs for to analyze the pyrolysis oil, the boiling point distribution of it to see the improved quality our catalyst makes, and also the pyrolysis gas so we can determine its composition and validate our experiments. Here is some thermal gravimetric analysis of our catalytic pyrolysis Opal Infinity zeolites. Now in this experiment, we're increasing the temperature in a nitrogen atmosphere, and we're measuring the volatilization of the pyrolysis products to determine the conversion. With low-density polyethylene, we see a temperature of 50% conversion at 460 degrees Celsius. With 1 weight percent of one of our catalysts, we're able to decrease that 50% conversion temperature to 420 C. And with another one of our Opal Infinity zeolite catalysts, we are able to decrease that temperature to 385 degrees C. With just this small subset of data, we can show that we can lower the conversion temperature with catalytic pyrolysis versus a thermal pyrolysis process. Our catalyst has higher activity at lower temperatures, and we're able to reduce energy costs. But what does that tell us about the pyrolysis oil products? Opal Infinity catalyst produces pyrolysis oil with a lower pour point and a lower gravity. The pyrolysis oil on the left is thick, waxy, and has a large amount of heavy hydrocarbons in it. The Opal Infinity catalytic pyrolysis oil on the left, the same 2 catalysts I've shown on the previous slide, has a much higher content of naphtha and is much more valuable. I'll give you more detail from our benchtop pyrolysis reactor. So this pyrolysis experiment was performed at 450 degrees Celsius in nitrogen. I'm able to show the higher activity with our zeolite catalyst compared to the thermal pyrolysis, and also the ability to control the product selectivity and increase the naphtha fraction. If you look at the top line there, you could see with the thermal pyrolysis, nearly 10% of unreacted polymer remains. With 1 weight percent of our catalyst A, we're able to decrease that to 5%, and with catalyst B, no unreacted polymer remains. Clearly, our catalyst has a higher activity than the thermal pyrolysis process. Now, we're able to analyze the pyrolysis oil to figure out the boiling point distribution on the table, on the graph on the right. We can use that data to find out the cut points in the pyrolysis oil to determine the value of our Opal Infinity catalyst. You can see with the thermal pyrolysis that very little naphtha remains, or very little naphtha is generated, and it contains a high amount of high boiling point waxy hydrocarbons. With 1 weight percent of our catalyst A, we are able to triple the amount of naphtha and decrease the amount of waxy hydrocarbons and increase the activity. With 1 weight percent catalyst B, which has even higher activity, we have 4 times the amount of naphtha, and we minimize the amount of heavy, waxy hydrocarbons. This is just a small subset of the data we've been able to collect. But what we offer at Zeolyst is a customized catalyst solution to your process. I'll let Varia tell you a bit more and summarize the value of our Opal Infinity catalyst.
Thank you, Nate. So why Opal Infinity? I think the value that the catalyst brings is significant here. As we've seen in the prior slides that Nate shared, you see the naphtha range, you see the more of the liquid product that you want as a chemical recycler. So we see the reduction in energy demand for pyrolyzing these plastics while enhancing the product quality. This enables to have a precise control over product distribution and final boiling point as well, ensuring a more efficient production of desired end products. By addressing and we can also address process bottleneck issues, and this catalyst can help increase the return on assets. As we mentioned, is a 1 weight percent addition to the process, and then also help lower the energy consumption, reduce the operational temperatures as well, leading to a less expensive material of construction, and improve the quenching and separation system downstream of the reactor, all while significantly reducing the carbon footprint, creating even ever-ending value for our customers by adding in our catalyst. I wanted to emphasize again that Zeolyst International, we pride ourselves on our collaborative and partnership and a partnership-driven approach with customers. And our mission is to provide exceptional value through technical collaboration and innovation. We want to deliver a more effective and better value to our customers. And we would love for you guys to come and talk to us. We're at the stand right behind this at AA26. Please connect with us on LinkedIn as well. You can contact myself or Nate to have a deeper dive and discussion in respect to the type of solution that you would need in your reactor system. And we also have the QR codes to be able to go on the website and browse through our other solutions that we have for EcoWaste and Zeolyst as well. We've been in the industry for a long time. We have been solving problems together with our customers for a long time. We would love to be a partner for you. Thank you.
Thank you.
So you guys can submit your Q&A if you have a question.
We would love some questions. I'm off the mic. Am I back? I think I'm off.
Oh, okay. Okay, we have one question come in. What are the current challenges for you in the current market situation? So I think given the way the market is right now, and I think that this can be looked at 2 ways. The market is going in respect to plastic recycling and what's happening there as well. I think European market has, it's ahead in respect to the U.S. market in respect to developing solution on the market, in the mechanical recycling, being able to have better separation, less contaminants, and compared to compared to what we have in U.S. In respect to chemical recycling market, I think right now is still somewhat in its infancy. It's still maturing. We're working with our customers to drive that value that they need because it is a very competitive market. There's a lot of different technology that sits in there. 60 to 70% of the market is announced capacity is pyrolysis technology. We know it's going to grow more, and it needs to become more and more efficient, and the catalyst can help you get there. Next questions, are your solution regenerable? I'll let Nate take that one.
Yeah, our zeolite catalyst is quite regenerable. The aluminosilicate framework of the zeolite has a high stability. So in many processes now, thermal oxidation is used to regenerate the zeolites or remove any coke. And in this, the pyrolysis reaction itself is, I would say, fairly mild compared to some other applications for zeolite catalyst. So yes, the zeolite catalyst is regenerable in this case.
And the second question is a piggyback to that one. Do you have number of catalyst cycles before requiring replacement, or are there possibility for catalyst separation regeneration?
Yeah, so we've studied reusing the catalyst in our laboratory. Obviously, I didn't share any data today on that, but we see that the catalyst is reusable before regeneration. As far as catalyst separation, if we're doing like a once-through solution where you feed a powder, it can be challenging. Depending on the quality of the char, if it's like a tarry char or dry char, it would be easy to separate out, say, a form material like an extradate or a bead. So it really depends on what your process is, and we try to match our catalyst for your process.
The last question we have right now is, how do your zeolite help with carbon footprint of thermal pyrolysis?
Okay, so I showed that our zeolite catalyst has higher activity, so you'll be able to process more plastic waste at a lower temperature. So if your reaction occurs at a lower temperature, then it's pretty straightforward that it's going to have less energy costs. I see another good question here. Can you increase olefins such as propylene? Absolutely.
Yes.
Come talk to me. AA26.
Yes. And how much your catalyst can sustain impurities such as chlorine present in the waste plastics?
Yeah, that's a challenging question because every plastic feed is unique. So what we try to do is we try to tailor the catalyst to the types of feeds you're going to see. And we're able to balance the activity and the stability of the zeolite. So I think it's pretty known at this point that no waste plastic is going to be perfectly clean. And we try to tailor the catalyst to if you have a dirtier feed or a cleaner feed by tuning the composition and the structure.
Okay, I think those are, we have another one just popped up. Here we go. How is the catalyst recovered when some char is produced? So, I mean, if the catalyst is a foam catalyst, it comes with the char. We form a certain size and shape that can be separated out from the char. So if you have a clean, dry char, that's the easy separation. If you have a char that still has some oil in it and it's a very liquidy mixed char, that's a harder recovery to be made. We do provide a solution as a once-through and as a regenerable. So it's a possibility that once-through would be better if you have a char that you cannot recover catalyst out of. Would your catalyst improve the recycling rate towards the production of circular plastic thanks to light fraction selectivity?
Yeah, I think the answer to that is yes, because the pyrolysis oil requires less processing after to make monomers if you have a higher naphtha fraction, right? So we're helping remove some of the post-processing by producing a pyrolysis oil that it has a higher naphtha fraction.
What is the most common end-user pyrolysis oil product at the moment? So at the moment, what we see in the market is it's using as a co-feed into a naphtha cracker unit. There's also possibility of using as a co-feed into a FCC unit. And there are other applications where people are using as a fuel substitute as well. So it depends on the end use. I think naphtha cracker, bringing it right back into into the circular economy, and the value chain is the bigger driver here. Another question is, what is the aromatic content in the naphtha fraction?
That's a great question. And the answer is it depends, right? We could tailor the catalyst. If you want more aromatics, we can tailor a catalyst to form more aromatics. Or if you want less aromatics, we tailor the catalyst to form less aromatics. It's really the solution that you're looking for that we're able to deliver a customized catalyst solution. Well, I want to thank everyone today and for joining our talk. And we had a lot of great questions, so we also appreciate that. And we would love to answer any other questions you have. So please just stop by and see us right behind here, AA26. And thank you, Faria, for the great talk as well.
Thank you, Nate. Thank you, everyone. Come and see us. We love to talk.
One of the standout advantages of Opal Infinity Zeolites is their ability to fine-tune product distributions in downstream processes. Unlike thermal pyrolysis, which often yields a wide molecular range of products, these zeolites enable precise control over end products,